Final exam review, question number 7. We need to solve 2 sine square minus sine minus 1 equals 0. So in this case, we have a quadratic equation, and we need to solve that quadratic equation by factoring. Just to remind you, you can replace sine square with x or a or any variable that you would like. So if you do that, you will end up with, let's say, 2a squared minus a minus 1 equals 0. And then you're going to factor this equation. And let me show you a special way of factoring. So in order to factor this, I usually make a grid like that. And there is the multiplication. So I'm reversing the grid here. I'm going to put the first term in the first box and the last term in the last box. So I will put 2a squared in the first box and negative 1 in the last box. I know that 2a squared can be factored into, it could be the result of multiplying 2a by a. So 2a times a is equal to 2a squared. Negative 1 can be the result of negative 1 times 1. So I'm going to put negative 1 here times positive 1 here, and then I will double check. So I will compute the middle term by filling these, the rest of the squares, or the rest of the blanks. I have 2a times positive 1 is 2a, positive 2a, and then negative 1 times a is negative a. If you add 2a minus a, you get positive a, which is not the middle term. So I know I made a mistake here. So by keeping this term positive and this one is negative, so I'm going to switch these around. I'm going to say this is equal to here. So this is equal to negative 1, and this is equal to positive 1, which will switch this to positive and the other one to negative. So it's going to be negative 2a. Now negative 2a plus a is equal to negative a, which is the middle term. So this factoring is right. So here is my first term. I'm going to say this is a minus 1. And here is the second term, which is times 2a plus 1 equals 0. Now switch back to sine and cosine. We know that a is basically sine x. So this is sine x minus 1 times 2 sine x plus 1 equals 0. You have two terms or two binomials. Their product is 0, which means either the first one is 0 or the second one is 0. So I'm going to do the math in a different color here. If I say sine x minus 1 equals 0, and then I solve for sine x, so I will add 1 here and I will add 1 here. So I get sine x equals positive 1, which means I need all of the angles that give me sine x equals to 1, and in my case I know this is equal to pi over 2. So here's the solution, pi over 2, and that would be my first solution. And then I will need to solve the second binomial. So I will have 2 sine x plus 1 equals 0. First I'm going to subtract 1. I will get 2 sine x equals negative 1. Divide by 2 both sides of the equation. You get sine x is equal to negative 1/2. I know sine is negative in quadrant 3 and quadrant 4. I'm looking for an angle x such that sine that angle is equal to negative 1/2. By looking at the unit circle, I see that is 7 pi over 6 in the third quadrant. And it is 11 pi over 6 in the fourth quadrant. And the reason I'm doing that in radians, because it gave me radians here, wants the solutions to be in radians. So 7 pi over 6 and 11 pi over 6, and I am done. Question number 8, I have 2 sine theta equals 1. I will divide both sides by 2 to solve for sine theta. So I will have sine theta equals 1/2. I know sine is positive in quadrant 1 and quadrant 2. I'm looking for an angle such that sine that angle is equal to positive 1/2, and I know that in the first quadrant it's pi over 6, and in the second quadrant it's 5 pi over 6. So the solutions are pi over 6 and 5 pi over 6. So you will need the unit circle here as well. Question number 9. Express the number 1 plus 5i in a complex polar form, and we need to round to the nearest degree. In this question, you will need to use the calculator. So you will be allowed to use the calculator for this type of question. We know that to convert from complex number in a polar form, I'm going to label these. This is x and this is y. So x is equal to 1 and y is equal to 5. I know that r is equal to the square root of x squared plus y squared, which is in this case the square root of 1 squared plus 5 squared, which is square root of 1 plus 25. So it's square root of 26. Theta is the inverse tangent of 1 over 5, which is y over x. Let me write the formula first. Y over x. So this is tangent, inverse tangent of 5 over 1, which is equal to 5. I know this point is in the first quadrant, so my angle is going to be in the first quadrant as well. And I know tangent is going to be positive. I'm going to punch that into my calculator, making sure I am working in degree mode because I have this. So it's in degree mode. So I'm going to say, double check first, and then inverse tangent of 5 is equal to 78.7. 78.7. I'm going to round this to a whole, so 79 degrees. So z is equal to, I'm going to use this form, square root of 26 cosine 79 degrees plus I sine 79 degrees. And here is my complex number in a polar form. Question number 10, prove the following statement. Your work should be legible and all of your logic should be clear and justified. The key here is to FOIL this. So let me just rewrite it again because it looks funny. So I have sine theta minus cosine theta all squared minus 1, and I need to prove that to be equal to -2 sine theta cosine theta. So I'm going to FOIL this, which means first term times itself is sine squared. First term times second term times 2, that is -2 sine theta cosine theta. And then second term square, which is positive cosine square theta, and then -1. So I started with the left-hand side. This one. And I need to prove it's equal to the right-hand side. Notice how sine and cosine, sine square plus cosine square is equal to 1. So let me write them next to each other first. So I know that sine square theta plus cosine square theta minus 2 sine theta cosine theta minus 1. This is equal to 1. So 1 minus 2 sine theta cosine theta minus 1. 1 minus 1 is equal to 0, so these will cancel, and I will end up with -2 sine theta cosine theta, which is the right-hand side. So I proved it, and it's correct. To FOIL, sometimes I use the box method if you don't know how to FOIL like immediately. So I have sine theta here minus cosine theta, and I have sine theta here, and then minus cosine theta here, and then I will do the multiplication of the grid. Sine times sine is sine square. Sine times negative cosine is negative sine theta cosine theta. Negative cosine times sine is negative sine cosine theta. This is multiplication. And then the last one is negative times negative, cosine is positive cosine square theta. So you can immediately see that sine square plus cosine square, and then -2 sine theta cosine theta, which is exactly this term. And then -1 from the left-hand side, and then you finish the proof. Question number 11. We need to convert this polar form into rectangular form. So I have r equals to 5 over 3 sine theta plus 22 cosine theta. I notice immediately that I have cosine and sine. They are missing r, and I have r on the other side. So I'm going to put a denominator of 1 under r, and I will cross multiply this way. 5 times 1 is 5. I'm going to keep that here, equals, and then r times the denominator, r times 3 sine theta, plus 22 cosine theta. You have to include the parentheses so you can distribute. Now we're going to distribute r inside, so you're going to get 3r sine theta. It doesn't matter in which order you put them. 2 times 3 is the same as 3 times 2, so multiplication is commutative. Plus r times 22 cosine theta becomes 22r cosine theta equals 5. We know that r sine theta is equal to y, so 3y plus, I know that r cosine theta is equal to x, so 22x equals 5. You can leave it like this, but if you want to continue to put it in this form, you're going to say, I'm going to solve for y. So I will subtract 22x from both sides of the equation. You will get 3y equals to negative 22x plus 5. And then divide by 3 every term. You get y equals negative 22 over 3x plus 5 over 3. And that would be the final answer. Question number 12. You have this form, which is IJ form, which is the analysis form. You can skip that and use this form, which is the standard position form. So I'm going to skip this form. The only reason I put it here because the online version has only the IJ form, not the standard position form. Now, to graph the vector u, it is negative 3, 5. So you go negative 3 to the left and 5 up. So 1, 2, 3, 1, 2, 3, 4, 5, and that is the end of it. So you're going to draw the first vector. That is my first vector. This is u. And then from the vector u, the end of vector u, you're going to imagine there is another axes here, I and j axes, or x and y axes, and you're going to draw the other vector w. So the vector w is 4 and negative 2, which means you go to the right 4 points and down, let me use a different color here. So 1, 2, 3, 4 to the right, and then 2 down. So that is the end. I'm going to sketch that. And that is vector w. Now the resultant vector is going to start from the origin, or the initial point of the first vector, and it's going to end at the terminal point of the second vector. So I'm going to start here and end at the terminal point of the second vector, and that is the resultant vector, which is u plus w, or x as they name it here. Now this is algebraically, graphically. Algebraically, you're going to say basically negative 3, 5 plus 4, negative 2. You're going to take first component, add it together. So you have negative 3 plus 4. And then second components added together, you have 5 minus 2. So that will result in positive 1 and 3 and 3. So the final answer here is 1 and 3. And as you can see here, the resultant vector is 1 and 3, 1 and positive 3. Number 13, you will find 3 minus I to the 5th power. We're going to use Binomial theorem. So the first step is to convert from rectangular form to a polar form, and then we're going to apply Binomial. So we need to find r and we need to find theta, and I'm going to leave them in degree form. So r is equal to the square root of, this is x and this is y, so x is equal to 3 and y is equal to -1. And this is going to be in the fourth quadrant, so that is important. Okay. Now, we're going to have r equals to 3 squared plus 1 squared, -1 squared, which is +1 anyways, so square root of 9 plus 1, which is square root of 10. And then theta is the inverse tangent of -1/3. If you plug that into your calculator, in degree mode, you're going to say inverse tangent of -1 divided by 3, -1 divided by 3, and the answer is -18. So I'm just going to write it negative here, -18.43 or 44. Because I'm rounding here, my answer is not going to be exact, and I'm going to leave it in degree form. Although I could find the equivalent by adding 360 degrees here in the fourth quadrant. So if I add 360 degrees, I will get 341.57 degrees. Now, I'm going to say 3 minus I in polar form is square root of 10 cosine 341.57 degrees plus I sine 341.57 degrees. Now, if I raise this to the fifth power, then that means I'm going to raise the polar form to the fifth power. According to Binomial, this is equal to square root of 10 raised to the fifth power times cosine 5 times 341.57 degrees. We multiply the power with the argument, plus I sine 5 times 341.57 degrees. Okay. Now, if you do the math, you're going to get square root of 10 raised to the fifth power is equal to approximately 316.23, and then cosine 5 times 341.57. So cosine 5 times 341.57 is equal to negative 0.03752 minus or plus I times sine 5 times 341.57 equals to negative 0.999296. Okay. The more digits, the more accurate it's going to be. So the real part is going to be 316.23 times negative 0.03751. Sorry. So this is going to be, let me actually multiply what I have first. Minus 316.23 times negative 0. The negative is, I multiplied the negative already. So 0.999296. So that times 316.23. The imaginary part, I got negative 316.007. That is the imaginary part. And the real part, 316.23 times negative 0.03752. I get negative 11, negative 12 approximately, if I wanted to round to a whole number. So the answer is going to be negative 12 minus 316, approximately 316i. That is approximate. It's not exact answer. So I just rounded to a whole number, and that would be the answer. Really doesn't matter if you use the negative or the positive, so it really doesn't matter if you want to use negative 18 instead. Now that is Binomial. Number 14, Binomial, you'll need to use a calculator for that, so you will be allowed to use a calculator. For number 14 and beyond, you will be allowed to use a calculator. So let me just do that in a different part.